Hello everyone, by popular request, I'm going to go through the mid-semester exam. So I'm just going to do all the questions and provide some commentary. In the video description I'll provide timestamps for the different questions, so if you want to skip ahead, feel free. Let's have a look at the exam. Alright, starting off with question 1. Most people didn't struggle with this question, which is good. It's fairly similar to the lab test, so let's crack on. 1A. Now, if you're really quick, you might be able to identify this as being an XOR gate. Just quickly looking at each of these first two gates here. So they're both AND gates with one of the inputs negated. So if we have A high and B low, we'll get an output here. And if we have B high and A low, we'll get an output here. And these two things are OR together, hence it's an XOR. So just running through it again. So if A and B are both high, outputs of both these AND gates are going to be 0. So output's going to be 0. So we can fill in that column there. A1, B0. That gets us 1 on the inputs of this gate, 1 here, or it's a 1. Same thing for the bottom gate, just we now have B high and A low. And then both inputs low, both AND gates are low, output's low. Okay, part B. Quite a few people didn't get this question completely correct. Now remember, we're working with 8-bit register whips here. Now we do this so you can't just, quickly plug the question into your disco board and check it, which you actually can. You just have to extend everything out to 32 bits. Anyway, let's think about an 8-bit. So we do FF plus F1. Leave some spaces there. So what's this going to add out to? So F plus 1 is going to be 0, and we'll have a carry. F plus F, what's that going to be? That's going to be E with the carry. That's going to be another F. Thank you, VS Codium. And then we're going to have a 1 from that addition of the F's there. So that's our result in 8 bits. OX1F0. Now this gets truncated down to 8 bits, so the final result is OXF0. Now what flags will this set? So we've got a carry out here, so that will set carry flag. Do we have an overflow? Now, a lot of people didn't get the overflow part correct. So we don't have an overflow. The reason why we don't have an overflow is because we've added two negative numbers, if we think about these as signed values, and the result that we've got has also been a negative number. So we've got -1 plus, I think, what's that off the top of my head? -6, -15 or -16? -15, I think. Anyway, in any case, we end up with a negative result at the end. This is, I think that's -16 off the top of my head. I don't know. I can't do these conversions very well myself. Yeah, so this is -16. That's -15, and that's -1. So yeah, so we do have a negative flag, however. A lot of people seem to get hung up on the idea that the CPU is treating things as signed numbers or treating them as unsigned numbers or operating some mode where it acts as if they're signed or not signed. The CPU always calculates all the results for additions when it comes to flags, both for signed and unsigned values. It doesn't really discriminate. Your program itself is what determines as whether or not the results are interpreted as signed or unsigned. Now, what other flags we have? We're not doing saturation, so we won't set a sat flag. It's not an overflow as I just described because we've added two negative numbers and the result was a negative. Now, if we had added two negative numbers and the result was a positive, that would be an overflow, for example. So think of overflow as if you're adding signed numbers, you get an unexpected result because, you add two positives and you get a negative or something like that. We don't have a 0 flag because the result's not 0. Yeah, the two flags we're looking for are carry and negative. Part C. So what exactly does this function do? I'll just quickly talk through that. So we load into register 2 a word from the address specified by R1, and then we do a post offset add of 4 to R1. Next we load into register 3 a word from the memory address in R1. Now noting that R1 has now had 4 added to it. So we've loaded 2 consecutive words of memory. We add them together, and then we are storing them back into R1 minus 4. So the original value of R1. That's the memory address it gets stored back to. Pass by reference or pass by value. This is a pass by reference. And the reason why it's a pass by reference is that we're passing a memory address to the data we're operating on. We're not passing copies of the data. If we pass the data in register 1 and 2 and add it together, that would be a pass by value. But no, it's a pass by reference. We're passing in R1 a reference or the memory address of the data, and then we're operating on that. So I'll just quickly type up an answer for this question. Okay, so that would be a good answer for part C of question 1. Groovy, let's move on to question 2. Part A of question 2 is doing some number conversions. I'll just whiz through and do this quickly. It's going to be 16 plus 5 is 21. What's this? So for the hex one, I'm just going to read off this binary here. All ones is an F. Now what do we got here? I like to count backwards from F. So we've got a, so that would be D. Sorry, that would be E. No, that would be D. That's E. That's D, and that's C. There we go. And what's the last one? Negative 83. Okay, what's negative 83 in binary? We'll do that first. What is negative 83 in binary? We do 64, not 32. Do you want to add 16 to that? 64 plus 16 being 80. Don't want to add 8. Don't want to add 4. Do want to add 2 and do want to add 1. We'll just quickly check that's correct. So that's 1 plus 3 plus 1 plus 2 plus not 4 plus not 8 plus 16 plus not 32 plus 64, which is going to be 70, 80, 83. Yep, cool. Now we need to take the 2's complement of that in 16 bits. Let's get this all set up in 16 bits. I'm jumping the gun there a bit. Okay, so we'll flip all the bits and add 1. There we go. That's our binary there. And what's that in hex? So it's OXFF, and then what do we got there? 8, 9, 10. So that's A and D, I believe. FFA D. I think that's a solution if my memory serves me correctly. Okay, so let's have a look at part B now. I'll just quickly note that we give you a table of the operators here. We did have a few people multiplying or adding. Please don't do that for these questions. If we give you an operator table, that's the operations we want you to use. R6, R1, R2. And in binary, I'll just quickly go through and do that. 1, 1, 1, 1. So I'm just looking at these binary values here and adding them together on the fly. Next up, what do we got here? So we want to XOR R1 and R2, and then we want to OR into R6, R0 and R1. Now let's do the XOR first. So that's the XOR of these two here. And then we want to OR that with R0. That's the value there. Beauty. Okay, so that's question 2. Once again, a lot of people got question 2 correct, so nothing too concerning there. Okay, let's look at question 3. Both question 3 and question 4 on the Midsem had fairly low averages, so I'll definitely talk through these questions fairly well. We give you some assembly, it's got a few problems with it, and we want to figure out, in part A at least, what the function is, what it's trying to do. Now, debugger and memory viewer are in bold here for a very good reason, because that's really where you want to start. Here's our program. Let's run the debugger. Let's have a look at it first. Immediately we're seeing some kind of function blfoo, and we're loading a memory address into a register, so it's a pass by reference. We've got loads and stores here, which implies that we're probably manipulating something in memory, and there's a string down here. Remembering from the paper, it's recommended we use the memory viewer. I'm going to open up my memory viewer and look at the string as we go. Okie dokie. Now let's get our registers up here. They're handy to have. Alright, first thing it's doing is putting a copy of R0 into R4, and then putting a 2 into R2. Okay, we're going to load. So it's loaded 98. I'll just put this in hex as well. Oh, it's 62. So we've loaded the second character of the string. Checking if it's 0, it's not. Pushing on the stack, adding to R2, and going around in a loop. So if we keep going through this, we'll see it seems to be pushing all the different characters of the string onto the stack. Okay. And it's going to keep going until it hits this 0. Remember, ASCII Z is null terminated. So I'll set a breakpoint at store loop. Okay, here we are now in store loop. Should have pushed all of that onto the stack for us. Here's our stack pointer here. Let's just have a look at the stack. Yeah, so here's our string on the stack. Well, except the A. So that's all in the stack there, groovy. Alright, R2 is not 0. It's going to pop R1. So we've got the E. Then we're going to store it. So R4 is a copy of R0 from before. Okay, it's put it where it loaded the first one from. Let's just whiz around this loop a few times. Well, I hope you can see that that is B, C, D, E backwards, so it looks like we're reversing the string in memory. Now we're checking against R2 here, but R2 is not changed in this loop, so that's never going to actually terminate. Well, we've reached the top of the stack, and we're probably going to have an exception here. That we do. So what's a good answer for part A then? What is the function trying to do, and how does it work? Well, a good guess here. There we go, that's an acceptable answer. It's trying to reverse the string in memory using the stack. Now looking at part B, there are 2 errors that have made the function not work properly. So the first error we can identify is that we've used the wrong kind of offset in the loads and stores. This is a pre-offset, which means it does R0 plus 1 before it does the load. That means it's always going to skip the first character here. What we can change this to is a post offset. So this is doing the same thing, except it's doing the add afterwards. So it loads from R0, then after that adds 1 to it. So I'll just quickly jump in the debugger, show you that this does actually fix that problem. R1 contains 61, the first character in our string. Now the other issue here is that it's never actually decrementing R2. Here where we have the add R2, we want to put a sub R2 one here. Basically, R2 keeps track of how many characters we've pushed onto the stack here. So if I just run through this loop here, every push increments R2 by 1. So you get to here, we've got 5 characters in the stack, A, B, C, D, E, groovy. And then every time we pop one off, we'll just want to store, we want to decrement that, sorry. 1, should do the last pop now. Okay. R2 is now 0. Our string is reversed. Looking good. And we end. Okay, that's all working properly. So let's quickly answer then part B. There we go. That would be acceptable answers for part B there. There we go. That's fine for part B. We don't need super long answers as long as you're getting the main, gist of the problem. That's good enough. C. A lot of people were, I might say, inventively wrong on this part. Let's have a look at the code. The issue that we have here is the use of register 4. Register 4 is a callee save register, which means that if our function foo wants to use R4, it needs to restore the original value of it when it's done. So say our main here was using register 4 for something, foo just writes over it, and the function calling convention states we're not allowed to do that. Describe two solutions to the problem. The two things we're looking for here, you could either use a different register. That's a very simple one. We just change the R4s to R3s. Or we can push and pop R4 on the stack. So we can do something like this. Do a push there and do a pop. Either of those are acceptable solutions. And then for your written answer, just something like this. There we go. Now, part D, which I've sort of done as I go through, was just to get all the problems from part B and C and fix them in the code. So if you're wondering why you've lost some marks for part D, chances are that you haven't done your B or C correctly, or you just haven't actually fixed the issues within the code. So this here is looking like we're all done with question 3. Let's move on to question 4. Question 4 here, okay. So what are we doing? We're doing a Caesar cipher. Okay, just the alphanumeric lowercase characters. Ensure we follow calling convention. So cipher 1 character, and then cipher a list. Okie dokie. I'm just writing myself some quick comments through. Both document my function and remind me of what I'm doing. Now we want to call our function up here, so I'll do that. Try applying a shift of 5, okay. It will decrypt to a readable message, that's cool. Cipher character. So we've got our ASCII table down here. Now if we go over decimal 122, we want to wrap around back to decimal 97. Now I know there is a typo in the hex table here. We did take that into account when marking. And we're very sorry if you wasted some time on the question. That should be OX7A, not OX80. My apologies. So yeah, it's once again, we have considered this when marking. Okay, so we have our character here, and we want to shift it, add R1, R2. If our character is now greater than R2, we want to subtract it so it goes back down into our ASCII range. 26. Yeah, I can do math. So we shift the character, we check if it's too big, and if it is too big, we do this. Otherwise, we just return straight array. Groovy. The first thing I'm going to do in my cipher string, so we just need to apply this function to the entire string. Actually going to move that into R1. Because I like to use R1 for my character here, because that's the inputs to my cipher character. So like in question 3, just using that post offset to operate on the string. Something that you should do, but I don't think we were too fussy on when marking, is that even when you do load that last character and it's a null, you do actually want to write that out into the output string space. It's just good practice. Okie dokie. So we load each character, check if it's 0, which means we're at the end of the string. If it is, we go to the end of the function. Otherwise, we cipher the character, store it back, and go around the loop. One thing we have forgot to do so far is push and pop our link register. We have an embedded function call, or a nested function call, so we do need to do this. That way, so the original link to the cipher string does not get lost when we range link the cipher character. That looks like it's all okay, so let's just run it. Opening up my trusty memory viewer. Step. Helps if I actually branch for the function. I think this might supposed to be a 25. Okay, what have I done wrong here? Hang on, did that just not do that greater than? And for the input of 122. Aha. I've compared the wrong thing here. There we go. Alright, I think we're good now. Maybe 26 was the right number. After all. There we go. The cake is a lie. We got our message out there at the end. So, as you can see, even I make silly mistakes at the best of times. So the issue there was I was comparing the wrong register up here. Now, the way I kind of picked up that might be the problem is I know that O and C, they were ciphering to T and H. It does help a little bit that, being a native English speaker, I know that, T and H is like, it's probably a word. I couldn't actually remember what the string was, but, TH is usually going to be a word. Now, Z was going to some other random thing, and so was the X and V. Which kind of hinted to me that my rollover wasn't quite working properly. So I just kind of checked my cipher character for a few odd inputs, and when 122 was going to 127, it was returning straight away. That kind of gave me a hint that I was doing something wrong. And yeah, it was just this compare. So that's a working solution here. So I'll just quickly talk through it. We going to put the output string address in R3 so I can use R1 for other stuff. Load a byte, check if it's 0, and if it is, we go to the end. Otherwise, we cipher a character. And store it back, and then go around in the loop. Keep going till we reach that null terminator, which we get on an ASCII Z. Beauty. Well, that's the whole exam. If you have any other questions, please let me know.